All right. Hello, friends. Do you mind if I take my mask off?
Yeah, that's fine.
All right. Just for audio reasons, I'll pop my mask off here. I'm here with Jamil, and this is for Discrete Structures, and we're going to get going on the exam. So I'll share the screen. We'll work off of screen 4 here. Not that it makes any difference to you out in TV land. Lots of side projects. Oklahoma Research Day is coming up. March the 2nd is the deadline on that. Now, what I wanted to make a video with Jamil about was the Discrete Structures exam. And Jamil, how long has it been since you just went out in the wild and wrote your own program?
I can't even say.
All right. So the idea is that we're going to walk through this kind of from scratch. And Jamil's got a good start, and I like what he has. But I want to grow from there. So what we're going to do is we're going to just start from scratch. Jamil's using a different software than I'm using. I'll drive on this computer, but the idea is we're just going to develop a code, and we're going to start from scratch, start from what we understand, and then we're going to build to where we are. Okay, so here's the question. It says, develop a collection of 4 different rules to generate the terms of a sequence. Generate a program for randomly selecting a rule and a starting point. Give the user the first 4 terms of the sequence and ask them for the 5th, and then tell them if they're correct or not. So I've got the YouTube video that shows how we do that with Java, but Jamil wants to do this in Python, right? Because we switched over from CS1 from Java over to Python. So let's just find out if this box can run stuff. All right. So first question, does this box have Python on it? It does. And it's Python 3. So I've got a folder called Git. Let's see what's inside of it. The reason I do this is source code management. And this just makes sure that we've got this code out there on the internet somewhere. Now, I've actually got a folder called Discrete Structures, so I'm going to go into it. And there we can see I've got a folder for exams. So let's go to the exams. And Jamil is squinting. So if Jamil is squinting, that means it's hard to see. Hey, yeah. This is great. All right, how's that for visibility?
That's good now.
Okay, so Jamil, you got to keep me honest, and that's going to make this go a lot better. All right, so I'm going to make a folder, and actually I'm just going to make a file. So let's do this. I'll call it, Atom is just a text editor that I'm going to use, and I'm going to call it, for sequences. I'm not sure I spelled that correctly. I'll admit that. That's right. Atom is a text editor. And I'm going to tell you that I'm already a little bit confused, right? So let's slow down and let's start with something that we know that works. So let's just start with print hello. So I'm going to save that, go back here. It works. Cool. Now, I already forgot what the question is. So let's grab this. Now, in Python, a really cool thing that you can do is this block comment. And I'm going to use that right quick. And the nice thing about a block comment is that I can word wrap with relative ease. Now, Jamil, let me ask you, do you have to do it all at once?
No.
What would be a smarter way for us to work through this?
To break it down in sections.
Okay, so we're supposed to make 4 sequences. So here's what I propose. Do you have any famous sequences right off the top of your head, rolling around in your head that you're just a big fan of that you want to start with?
We can start with the Fibonacci one.
You know what, Jamil, I'm going to disagree. Let me elaborate on that thought just a little bit. I don't walk up to my friends on the street or wherever I run into my friends and be like, hey, I was thinking of a sequence the other day and it made me think of you. To me, that seems weird. So instead, let's just go to the book. So I'm gonna stop my share right quick. And we're gonna change the camera. I think I've got the technology to do this. All right, now go here. And I need to, oh, 1 second, technical difficulty. There. Okay, so
I have that picture too from earlier.
that's all good. We're making a video for the folks out in TV land, so it can go nice and slow. Now, page 165 in the PDF of the text is covering sequences. And they give some nice little explanations of what sequences are. And the reason why I wanted to do the book is it actually gives an easier one beforehand. So there's that. So this is a progression, but I'm gonna tell you that I don't really understand that. The initial term A and the common difference D are real numbers. Well, if they're real numbers, silly heads, why didn't we actually just use the words initial term and common difference? So let's go. Let's change the camera back. Let's share our screen. We're going to share screen 4. All right. And now let's get started. So let's just say our initial term equals, I'm going to make it 4. And then our two. Easier to see?
Mm-hmm.
Okay. So here's our first sequence. All right, so let's do this. Let's do and I've had some people have some problems running a code like this, so we're just going to run it. Cool. Although I got confused, I didn't really understand what happened there, so I'm gonna do this. Now let's run this. Okay, our index goes 0, 1, 2, 3, 4. Cool. I think I am able to come up with what I'm going to do here is I'm going to say equals initial term plus common difference times
2, right?
Index. Right. And so what should happen is that we should be able to get it to pop off and be like, okay, next term is going to be initial term, which is 4 plus common difference, which is 2 times index. So 2 times 0 is
0.
And 4 plus 2 is
6.
Sweet. Wait, what's 4 plus 0?
4.
Okay, so let's do it this way. All right, let's go see if this works. Cool. Oh, crap. It's confusing. I got to get rid of something. That's just, I'm sorry, friends. My brain does not fire on all 8 cylinders. Okay, so 4, index 0, and then 6, 8, 10, and 12. What do you think?
Oh, that's right.
Difference is always 2. I like it. Okay. So, all right, I might have bricked it, so let's just run it again. Still good? Okay. All right, so let's go back here. So we need to do something. Here's our first sequence. This is not going to be unique to our first sequence. We're going to do this up here. This junk here is part of our first sequence, so we're going to move it down here. All right, so all that goes together. Now let's go get our second sequence.
Oh, you did that so you can eventually do the, where they have to guess the fifth term. That's why you put the, how many numbers to print equals 5. Okay.
Yeah, because eventually we're going to make that 4. And then we're going to have to do something. We're going to have to do something. I haven't quite figured out quite what this is yet. Okay, the next one we're going to do is the Fibonacci sequence. So let me stop our share, and I'm going to change our camera. Okay, so this is a classic, recurrent relationships. The reason this is a classic, they don't actually talk a whole lot about Fibonacci in this book. So chapter 5 has a biography for Fibonacci. Guy is crazy. But essentially here's the part that we need. So f of 0 is 0, f of 1 is 1, and the recurrence relationship is our next term is equal to our previous term and the term before that. Okay. And share screen 4. Okay. So all right. So it says f of 0 and f of 1. And then it's kind of confusing when you do that way. I'm going to say, instead we're going to do it this. We're going to say two terms back equals 0. And then we'll do now I'm going to do okay. So this is not fair. I'm kind of cheating on this just a little bit. I'll admit that. See if I can slide it over there. We're going to just run this. All right, so 0, 1, 1. And at this point, it's too soon to tell if that's going to work or not. But 0, 1, 1, 2, 3, 5, 8, 13, 21 are the first few terms of the Fibonacci sequence. Now, the reason I said it's not fair, that I've been playing with this, I've got it in my head pretty tight. So here we go. The idea now is this is the recursive part. We're going to take and we're going to shift everything over a little bit. So 2 terms back is now going to get what we had for 1 term back. And 1 term back is going to get what we had for our current term. And then again, we're going to run these 2. So line 27, what that does is this is the definition of the algorithm. The definition of the algorithm says, I should probably make a space here, and I should make a
Do you
space here.
still need this current term here on line 23?
So let's talk through that right quick. That's a good question, Jamil. Line 19, all right, line 18, that's where it all starts. So line 19, what is that?
The 2 terms back equals 0. That's the first element, right?
Yeah, and that's the definition provided by the book. Okay, line 20 is just printing that off. Line 21.
And that's the second term.
Yep, the definition again. 22 is printing that off. What's line 23 doing though?
It's adding the first term and the second term to give you the third term.
Yes. The way I'm looking at that is our recursive step. That's our recursive calculation. And so on line 26, I'm sorry, on line 23, that's when we're doing the recursive step, which is it goes back and grabs previous 2 to define the current one. 24 is just printing that off. Line 25 is blank because now we're going to the next step. And I'm going to delete this space because all these go together. We have to shift back 2 terms back and update it because we're gonna index forward. And then, you know what? I'm confused. I think let's slow down just a little bit. Let me do this. All right, so this is the joy of coming to my office, because I got lots of nice little toys that make life a lot easier. All right, so we've got the book, and in the book we have f of 0 equals 0. So we'll start with, and then we also have, and then finally the book gives us this recursive term. Okay, so I now want to find f of 2. We know by definition, f of 2 is going to be equal to f of 1, which we get from this, plus f of 0, which is equal to 1 plus 0, which is equal to 1. Now I want f of 3, which is equal to we get that f of 2 we get from up here, f of 1 we get from the definition. Now we're going to do f of 4.
Which is f of 3 and 2, right?
So f of 3, oh, got to finish the joke. All right, what's f of 3?
F of 3 is, wait, for this one?
Yeah.
F of 3 is 2.
Good. And what's f of 2?
F of 2 was 1.
Okay. Now let's do f of 5. Go for it, Gino.
F of 4 was 3 plus 2.
Right. Good. Now do f of 6. And you might slide your paper just a little bit so you can There you go.
And then f of 6 is f of 5 plus f of 4, which gives you 5 plus 3, which equals 8.
Okay. So I'm watching Jamil do this, and I'm feeling like we've got a good handle on it now.
Mm-hmm.
Okay. Now, I'm going to go back so you can make sure that you can see our faces. I'm going to share screen. There we go. Okay. So now we're going to come back to this. And I don't like this term anymore. I'm going to call this f of 0. And I'm going to call this one f of 1. Okay. Now I need to fix some other print statements just because. Now we're able to come to this term. And I'm gonna rename this. I'm gonna call it f of 2 equals f of 0. Okay. Now let's change our terminology now. And let's say I'm going to call this f of n minus 2 equals f of 1.
Mm-hmm.
And f of n minus 1 okay. All right, so let's see how many terms this prints off. It gets a 0, 1, 1, and 2. All right, we're getting close. This is close to where we want to be. I'm just going to copy this. I'm going to paste it down here. Now we've got to make some adjustments. No, I did that wrong. Okay. So this adjustment says our new f of n minus 2 for our next iteration. Okay, let me slow down just a little bit. Let's just see if that printed pretty. You know what? I think it would look cooler if I did it this way. Grab this. Okay, let's see what that looks like. Cool. Now, there we go. I'm going to grab this. Actually, I'm going to grab all this. I'm going to paste it right here. Move this border over just a little bit. Okay. Let's run that. So 0 is the first term for f of 0, 1 for f of 1. Now we need to come here. Back it up here. Okay, let's run this, see what I screwed up. Cool. So we make a little note. 0 and 1 are given by the definitions. We calculate the third term, which is 1. And now we're starting to make sense of this, hopefully. Here's what I think, though. One of the ways that we could do this is actually with a for loop. But you know what? Do you know what the difference between a for loop and copy and paste is?
No.
A for loop does tend to be easier to work with, but copy and paste works just fine.
Mm-hmm.
So for now, we had a for loop up here. This is our first sequence. Our second sequence is the Fibonacci sequence. So we're just going to let this one go. I'm going to copy this. What is our fourth term in the sequence, considering that we started with f of 0? No, as far as f's go.
Oh, f's 3, right?
Yes. Okay. So n minus 2 for f of 3. So 3 minus 2 is 1. 3 minus 1 is 2. So f of n is going to be f of n minus 1 plus f of n minus 2. We'll print f of n. So come up here and grab this. And just because I'm a stubborn, crotchety, old, simple-minded individual. Okay. Calculate. So 2 is the fourth term in the sequence, f of 3. I will admit these lines are starting to confuse me, so I'm just going to comment them out. Zero, 1, 1, 2, 3. Yep, that feels good. And we're going to stop there, right? Let's run this and just make sure it prints. Yeah. Okay. So 0, 1, 1, 2, 3, 5, 8, 13, whatever. Those are working pretty good. Now I'm going to do something right quick. The reason why I do that is because if anybody has access to this, you can just click on this, go down to Discrete Structures, Exams, and there is 4 sequences. And we can see all of the code that we just written is just on the internet. Okay, so the other thing that I wanted to show you, in case folks had forgotten, once you go to the syllabus, so this is just, I use this a lot. It's tinyurl.com/SwasuJeremy. That redirects to this page, and it's got a link to all the syllabuses. Here's the discrete structure syllabus. I do my best to keep this stuff up to date, but
I think it's the second one.
kind of a handy folder to have is this one that has this, because you can come in here and you can grab the PDF of the book. So I'm going to download it. You shouldn't have to sign in. Actually, let's do this way. Downloads, show in folder. Crazy number of, no, I want you to open with Adobe. So I can do Control F, which is important to me. Come on. Oh, this button. There we go. So 2.3. No, sequences. There we go. And this way we can move a little bit faster. So here's, this is the geometric one, that one that we did first. Arithmetic, that's a better one. That's the one we used. Recurrent relationships. Here's the Fibonacci sequence that we had just been rocking along with. Okay. That's a fun one. We could do our term is equal to 2 plus 3. That's just a different arithmetic sequence. See if there are any other good ones in here. Oh, there's a fun one, n squared. So let's just go do that one right quick. All right.
How's it going?
Oh, we're recording a video for Discrete Structures on how to do things. No, this is the joy of checking in during office hours. Jamil made an appointment and our department chair just popped in to check on how we're doing. So if you needed to take care of anything like course substitutions or grade changes or dealing with hard to deal with faculty, you could have the opportunity to solve this right now, and you could speak your mind to the department chair. So I encourage all of you to take advantage of office hours. So
There you go. I'm ahead. Haven't seen the stuff.
yes, I love it.
It's awesome.
Yeah, it's bad.
Yeah.
I'm gonna get home
D-
just in case.
d-
And I'll see you in the morning.
Well, no, let's hope not.
Lord,
No, let's hope not. Let's hope we get a snow day.
No, it's too soon.
I'm rooting for snow days.
No.
All right. Truth be told, you can have a snow day if you
I'm
want.
rooting for snow day.
Okay, good.
I'm just teasing. See y'all.
Thanks,
See
Dr.
ya.
Sweeney. Okay, so I'm just gonna get stupid lazy. Jamil, do you know how to get stupid lazy on this one?
You could print the first
I,
one.
I like how you're thinking about doing work. I'm just not. So let's go grab this. Let's see. What do I need to keep? Let's do this. If you want to know what makes great programmers, it's the ability to copy and paste. Kidding. All right. There we go. Dang. Done. Look at that.
Wow, that one was easy.
Man, I am just so good at programming. No, that's not the button I needed. There we go. Do you agree that that's correct?
Yep.
Nice. That's 3 out of 4. Let's get, while we're getting lazy, let's do the for sequence. Okay, now I should have been doing this a lot more frequently, but my brain just went completely blank. No. That is not the command that I wanted. There we go. Math.factorial. So this is just my internal memory and its awesomeness. Pretty sure I have to do that. Okay. Maintain good code hygiene. Run it. Okay. So it says our first index for the factorial, 0 factorial is 1. Do you believe that or not?
Factorial. Factorial again is it multiplies the.
You ask these questions like I should know the answer to them. The thing that one of the secrets I want to let everybody know is I don't remember anything.
Yeah, I forgot factorial.
So one of the important definitions of the factorial is that 0 factorial is 1.
1.
And the reason that's an important definition is that when you multiply everything, so the way you calculate n factorial, it's n times n minus 1 factorial. So if you had 1 times 1 minus 0, and you did the factorial of that, if this definition wasn't true, then anything times 0 would become 0.
Mhm.
And so in this case, 5 factorial. So n, it's n times 5. So n is 5 times 4 factorial. What's 4 factorial? It's 4 times 3 factorial. What's 3 factorial? Da, 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 da.
Mhm.
Right? And you keep doing the recursive loop till we get down to the bottom of it. So anyway, that's factorial. And the important definition is it goes 1, 1, 2, 6, 24, 120.
Looks like that's what you had. Yep.
1, 1, 2, 6, 24. Yep, that's good. Cool. All right. So now we need to go and we need to, it's 4:33. Do you have a ride home if the snowstorm hits?
Yeah, I got it.
Okay. Okay. So let's go back to the code. Now we've got a bunch of crap.
Now we have to do the part where
Now we've got 4 sequences. Now what do you want to try to do next?
the user randomly selects. Randomly selects it, and then they guess the 5th term.
Okay. So every time we're gonna need, let's talk about this right quick. So I'm gonna set up a little quiz. I'm gonna say next term equals 42. Now, Jamil, do you understand the reason why the answer to life, the universe, and everything is 42?
No.
All right. This is from a 1970s book by Douglas Adams called The Hitchhiker's Guide to the Galaxy. And this is one of the few cultural references where they ask the question, what is the meaning of life, the universe, and everything? And in this classic novel by Douglas Adams, Hitchhiker's Guide to the Galaxy, the answer is 42.
Why is that?
Okay. This is called useless trivia, but oh no, not that one. Let's go back to this one. So
I've heard that before.
If you look for ASCII codes, the ASCII code for 42 is the star. Now, all right, what means in bash scripting? Not good answers. It means everything. So let's just do this. So again, Douglas Adams, cultural reference. There's lots of people that have lots of different ideas on why this is what it is, but this is just kind of a cultural reference. Anyway, let's elaborate on that. The reason why I'm going to do this, I'm going to set up my quiz. So let's make a note. So make sure we haven't bricked anything yet. Cool. Starting the quiz part. You know what? I'm going to add some escape characters. Just to make this look pretty. Make sure I haven't bricked it. All right. One of the things I want you to notice, Jamil, is I trust that I screw up everything. And that's why I constantly come back here and just run it. Okay, so the next term, and I'm going to ask, I'm going to say user answer equals input. What is the next? Oh, okay. No, wrong button. Print. So this is a test, right? And so we know that the next term is 42 because we, we wrote it that way. And says, all right, so what is the next term? 42. You are not correct. This is just a weird little Python thing, so we're not going to worry about it too much. Okay, save it. Let's run it. So basically, this is getting entered as a number, but the output of input request is always going to store it as a string. And so I'm going to convert the string for what we start as next term. I'm going to convert it to a user answer. Okay. Now, here's a problem with this. Is that always supposed to be what we're supposed to have is 42?
No.
But it is this time when we hard coded it.
Mhm.
So what we need to do is we need to have some way that we can call the first function. So I'm going to say this. I'm going to say function index equals 1 because we're going to run the first one. I'll say if 1 is the same thing as function index. And for those of you that didn't have CS 1 or 2 with me, the reason I do that is if you say some integer is equal to a variable and you don't have the comparison in there, Python automatically gets pissed and tells you, no, you can't do that. But if you say some variable equals a number, it'll be like, okay, I don't get why you're telling me this. And why did you put it in an if statement? So this is just a way to guarantee that you're not going to screw up your if statements. Okay, so I'm going to say all right, so what this means is if 1 is equal to our function index, then I want to go get the next term. And to do that, I'm going to run function 1. So how do we do that? Well, okay. Of course, I'm going to copy this. Let's come up here. Let's see. Hello. Things could always go sideways. I know this. And now we need to kind of index everything in to let people know. And so now I can do a calculation. I can say next term is going to be equal to, which I think the only place that I used this ever was here.
Yeah, I think you'll use it on this one.
Okay, so next term is going to be, so we'll grab all this. Our initial term, common difference plus, let's try this. And because I'm not an idiot, and I know I'm not good at numbers, and if you people are like, you're cheating, you're giving yourself the answer. Yeah. Okay. It's mad. It's mad at line 52. So let's just copy this. Okay. Might have fixed it, might not have. I don't care. Okay. What is the next term? 42. You are not correct. But we know that that should have worked. Okay, so let's run this again. Run it again. Okay. Now it says, starting the quiz part, here's our first sequence. 4, 6, 8, 10, 12. The next term is 14. What is the next term? 14.
Should work.
Let's go look. Jamil, I think I know what the problem is. Are you familiar with the phrase, the spark didn't jump across?
Mm-mm.
So the idea is pretty straightforward. Here we have a function. Here we have the end of what we're doing in the function. We left one key part. You actually have to
return it.
Yeah, so that was just my programming error, and that's why this happened. All right, let's run it. 14. We are gods amongst mortals. Okay. And again, nice thing about that, you come over here to this one. All that code is now there. Okay, now let's come down here and let's do this. LF2. And I'm terribly lazy, so I'm just going to copy this. Okay, now, let's go Sesame Street it.
Wait, why'd you make that one 2 right? Why'd you put 2 right here? Wouldn't that be 1?
Nope. So if our function index is 1, it's going to run the one that we already have working.
Mm-hmm.
We run function 2, now it's going to run, now it's looking for something we don't have described yet.
So then why is the function index equals 2 above the if 1 equals function index?
Oh, so this is the start of our if else stack.
Mm-hmm.
And so we wanted to skip over this function and go straight to this function. So we're going to set it, function index is 2. It's going to skip over this one now, and it's going to go to this one.
Oh, okay.
So
I see.
yeah, this code just got
I see
buried.
now.
All right, but we got to go define this now. And Jamil, onus is on you, your young brain. Don't let me screw it up. We have to return our variable when we're at the end. Okay, so I'll take care of the brainless. Now, Jamil, be honest. Is that ugly code? Should we have done a for loop?
Yeah.
I agree. Okay. Now we're going to do
Return f of 1, right? Or f.
Okay. Still tracking?
Mm-hmm.
Okay. All right, starting the quiz part. 0, 1, 1, 2, 3. It's the fifth term. The next term is 3. After the function call 2, the next term is 3. What is the next term? 3. You were correct. Run it again. Let's try 42. You were not correct. This is awesome.
Okay.
Okay. Now let's go back down. Because I'm lazy and I don't type stuff. So I copy paste a whole bunch.
And then you would change the function index to 3, right? Yeah, that makes sense to me then.
So let's say that that's going to go for 0, 1, 2, 3, and 4. So let's call the next term is 5 times 5 and then return. Okay, let's try it. Jamil, why does my code always get so angry at me and hate me?
I don't know.
You're going to fix this one.
What's it saying? Line 66, right?
Mhm. What's not defined?
How do I scoot this over?
Here, just hit that button.
Oops, wrong button.
No, that's all good. It's all good. And then just Alt Tab. You just use the keyboard. You go Alt Tab, and then you can go over to that.
Line 66 for indexing range.
So it's defined on line number 56, but why is it that we can't see that on line 66, 10 lines later? Now, this is a computer science 1, computer science 2 kind of question. And the answer is because it is defined inside the function, it only lives inside the function. And so the scope of the variable is only inside the function.
It's only in this.
Yeah. So when we hit line 62, how many numbers to print ceases to exist? So what you need to do is grab it from line 56, copy it, and then paste it down below.
And paste it
After 65. All right, Control S. That saves it. Now go over here, hit the up arrow, smash the mash button.
What's the mash button?
Oh, enter.
Ah.
Okay. Oh, just once. All right. After the function call 3, the next term is 25. Jamil, what is the next term?
The next term would be Squaring 25. So then 36.
No.
No.
After function 3 call, the next term is 25, so the answer is 25.
Oh, 25.
Because
yeah,
I'm not going to
25.
do math. That's why I got a computer.
I forgot that you
Punch
had
it
that.
in. It's because I'm lazy, man. All right, now run it again and try the wrong answer. You gotta hit the up arrow first.
Oh.
Sweet. Okay. You got 5 minutes. Actually, when do you got to disappear?
Mm,
You got 5 minutes.
yeah, I go.
Fix the next one. Or I mean, if you got to go sooner, that's okay. But in 5 minutes, I got to go pick up my family, and I got a turkey in the oven.
No, I'm messing it up.
You know what I would recommend?
Just copy and
Line
paste.
84, copy and paste. And Jamil, it's not because you type bad or anything. No, just line 81 through 83, right?
81.
Or 78 through 80. Just one of the little LF blocks.
Oh, what did I do there?
You hit the triangle. So hit the triangle again, it'll expand it.
Oh, okay.
And now you can just highlight it. There you go. And go to the end of where it says next term. So not end of line 80. Go up one line. There you go. Go to the end of that line. All right. Oh, there you
There we
go.
go.
Copy it. Go down to 84. Wait. You're indented one tab, so that actually would put it under the elif part that starts on line 81. You want to hit the backspace button. Now paste it in. Okay, now Sesame Street it.
If 2 4 function index.
That's still okay.
No, that's okay.
Yep. Control Z is your friend.
Next term equals function 4. There I go.
That line is not correct.
Is not.
Read 86 again.
Oh, I have to fix that.
It's a minor thing, and I know it wouldn't have caused any problems, except I'm not smart enough to remember that for later.
And then print.
Remember, line 54 is your friend.
Yeah, I should have just copy and pasted
No,
it.
no, not saying you have to copy and paste, but if you need a mental reference, because I already forgot how to do it.
And then print.
Now, remember, when you're defining functions,
I gotta return it.
you got it. Well, good point. And don't forget that. But line 64 needs to be indented. So basically, 63 in Python is saying this is where the function starts. And then as long as you indent underneath that, you're within that block of code. Perfect. Now,
No.
and then backspace one time so that you're after the for loop. Now, just like on line 60, you want to define what your next term is going to be.
This one was which one was this? Factorial. So then
You could copy line 68 if you want to. Computer, why are you being weird? No, 68.
68. Oops, my fault.
No worries. They are awfully close together, and I see what you were doing, but no, 68 your friend. Nope. Controls actually. And okay. So that line or that indentation point says you're right after the for loop, but you're still inside the function definition.
Mm-hmm.
Now, index is no longer going to work because index was just something that you had inside the for loop. But if you change index out for 5, it'll work.
Oh, right here.
Yes, sir.
And then return.
I like it. Okay, I have one problem with this. I'm not actually smart enough to remember what the next term is. So I want you to copy line 61 and then paste it after line 70. No, 61, the next one.
61.
Save it. If you hit Alt Tab, you can just go between different windows.
And then up once.
Yes, sir.
Enter. Yep. And then
Read that closely.
oh,
It says starting the quiz part, our third sequence is in squared.
no.
Okay, Jamil, you didn't catch what I was saying.
Wow.
Read that. It says starting in the quiz part, our third sequence is in squared. Which sequence are we trying to figure out? We did the geometric, the Fibonacci, arithmetic, Fibonacci, squared, and I thought we were doing the factorial one, which would be the fourth one.
Yeah, you're right.
But no, read it. It says our third sequence is in squared. So it's not doing the third, it's not doing the fourth one, it's doing the third one. Go to the code and fix that. So scroll down. Line 77.
77. Oh, I see what it is. Took me a second.
No, it's all good. All right, save it and run it.
Control S, and then Control Tab.
Alt
No,
arrow.
Alt Tab.
Yep. Up arrow.
Which right? Oh,
Run it again. You get it wrong. Sweet. Okay, Jamil. Now we got to make one more fundamental change. Go back to your Python code. Delete the number 4.
do random,
Yep.
and function.
How about 1, 4? Run it. I don't think that's going to go.
You
But
don't
run
think
it.
that'll work?
Run it. Let's just run it.
Oh.
Now, here's a really disheartening thing. I still don't think it's going to go. But let's try it. Let's run it.
Name random is not defined.
Highlight that whole line. Name error. Yep, the whole thing. Press enter. Now, hold Alt, and then just tap the tab key. Now what you want is a new tab. I want to Google search it. Name error. All right, solved. I like solved. Flutter IQ.
This one?
Yeah, let's try it. Okay, I was wrong. Close that tab. All right, let's try this again. Do the top one instead of the second one. Ooh, highlight that. I like their random.randint.
Where's that?
So their code right here, highlight that after the equal sign. Yeah, copy that. Now, scroll down just a little bit. Import random. Okay, cool. Go back. So hold down the Alt key and just tap the tab. And let's do.
Oh, I have to import random right there.
Yeah. I screwed up. You're going to have to tap. You're going to, yeah, do import random. And then do random.randint. No, delete one more time. Okay, use the down arrow. And over just a little bit. To the start of random. I'll go the other way. Yeah, because we're going to do this line of code here. So it'll
Oh,
be
random dot random.
Yeah. Now, I don't have any faith in the code that we have there because I might have screwed it up. So what I want you to do is after line 79, I want you to print off what the function index is.
Wait, say that again?
Print off what the function index is. Now you could type function index, right? And so as soon as you see, type function underscore index, and yeah, you just scroll down with your down or click it, that'll work. Now, the problem that I have with that is I won't be smart enough to remember that we just happen to randomly print that off. So I would have to do something like what I'm doing on line 83, which is I got quotation marks out at the front. And then I say like function index is. Comma. And then function. It auto completed. Just press enter and it should get you close. Yeah. All right, now run it. So nope, hold the Alt key down, but just press the tab once. Nope, hold it down. Oh, press it again, tab again. There you go. Okay. Now the up arrow. Cool, you got two. I think you can get away with just enter and then the up arrow. We got four. Cool. We got four again. Boo. We got two. We got one. Hey, you know what that means?
We got like all of them.
1, 2, 3, and 4. We got all of them. Now, make sure that this code exists. Oh. Cool. Now, here's the $1 million question. Can you go to github.com/swasu and find this code on your laptop? I'm going to stop the screen share. We're going to watch Jamil's face on camera because it's going to be awesome.
And do I have to have an account with GitHub?
I don't think so.
Okay.
Just search for GitHub space Swasu. Yep, top one. And then repositories, click on that. And then SWASU CS Python examples, the top one.
Oh, yep.
And then discrete structures. Exams. And 4 sequences. Scroll down to the very bottom and see if any of that code looks familiar to what you just wrote.
Oh, wow. Yeah, it's the exact same thing.
That's fun. All right, friends, I'm going to stop the recording there. Thank y'all for your time. Have a good day.